Hi again, this is Sami. I'm going to revisit some of the exponent laws. And here, the first question. So negative exponents, we have 3 to the power of negative 1 minus 3 to the negative 2 all over 3 to the power of negative 1, 3 to the power of negative 2 multiplied. So the top one you're minusing. So the only way you could do this is by changing this to positive exponent. And as I'm saying, x to the negative a becomes 1 over x to the power of a. So this will become 1 over 3 to the power of 1. When it's to the power of 1, you don't have to put 1 on top of there. It's an invisible 1. And this will be 1 over 3 squared. How about the bottom? The bottom, we have two things or two numbers that are multiplied. The numbers are the same, so the same base. In this case here, instead of changing them to 1 over 3 and 1 over 3 squared, what you could do is just multiply them first. And when you multiply them, you don't get 9. It'll still be 3, but you add the exponent, and that will give you 3 to the negative 3. What's the next step? The next step, this is going to be 1 over 3 minus 1 over 9. And this here will be 1 over 3 cubed. Okay, because that's basically using this rule right here, or this law where negative exponent, you flip it and you make the exponent positive. So in this case here, the top, I'm going to do common denominator. So it will give me the common denominator there is 9. And so 9 divided by 3 is 3. 3 times 1 is 3. That's what you get there. And that's the way I do common denominator. 9 minus then. And then 9 divided by 9 is 1. 1 times 1 is 1. So that's what you're going to get on top. And the bottom, just 1. And the 3 cubed, I'm just going to change that to 27. Here, 3 minus 1 is 2 over 9 divided by 1 over 27. You know, this is here, your main fraction, so that means division. And you could change division to multiplication by flipping the bottom. So that is going to become 27 over 1 if you wish. 9 goes into itself once. It goes into 27 3 times, so reducing fractions. And then you have 3 times 2 is 6 over 1, and you don't have to write that over 1 in this case. Okay, so let's move on to the next question. So here you go. There's another question. It's a bit easier than the first one. I started to do a shocker. This one is a bit easier. So negative exponents, the same thing here. I got to change them to positive by flipping. So this would be 1 over negative 2 to the power of 3, changing the exponent to positive. Some students will change that to positive as well. That's not an exponent. You keep it as is. You only change the exponent to positive when you do that. And this here, you change it to 3 to the power of 2, which gives me in turn 1 over negative 8 plus 1 over 9. Now, always when you're adding fractions, if you have a negative in the denominator, make sure you get rid of that and put it on top. You don't get rid of it. Actually, you just switch it to the top, so it becomes negative 1 over 8. And as we talked in earlier lessons, when you have negative 1 over 8 is the same as 1 over negative 8 is as same as negative 1 over 8. All of these are the same. We don't like this way here because if we're adding fractions, we don't want to have the negative on the bottom right there. Okay, now after this, you know, the common denominator is 72. And I do the common denominator differently. It's very easy. Just go 72 divided by 8, you get 9. The 9 that you got multiplied to the top, that gives you negative 9, plus divide 72 by 9, you get 8. 8 times 1 is 8. So this gives you negative 1 over 72. Next question. So here's another one. So we're looking at this, and the first thing we see, 7 to the power of 0. Yes, that's 1. So anything to the power of 0 is 1. But the issue is here. Now we have these with negative exponents. We have a negative exponent outside the brackets. One thing you must be aware of, that you cannot distribute that negative 1 into this exponent and the exponent. You're not allowed to do that. You know, as if you do that, this will be wrong. So if you're looking at x plus 2 squared, and if you go, oh, I'm just going to distribute the square in here and there, you're going to get x squared plus 4. And some students would make that kind of mistake. That would be wrong. X plus 2 squared means it's x plus 2 times x plus 2. So square means the thing multiplied by itself. And if you FOIL this, you end up with x squared plus 4x plus 4, which is the right answer. Definitely, it's not this one. That one would be wrong. So this is your right answer for that. So that's why you cannot just distribute the exponent when you have a minus sign right here. Okay, so how about now, what are we supposed to do with that one? Okay, what we're supposed to do is basically refer to that rule right there again. And it's changing that 4 to the negative 2 as 1 over 4 squared, and 2 to the negative 3 as 1 minus 2 cubed. Keep that negative 1 there. You cannot, you know how I said you could flip stuff if you're like, if you have something to the power of negative a, you could flip it and make it y over x to the a. You cannot do that unless you have one fraction. Here we have two fractions, so we still have to simplify this and see where this is going to take us. So this will give me 1 over 16 minus 1 over 8 to the power of negative 1. We're going to do common denominator on the inside there. And that the common denominator, you know, when you're doing common denominator, you look at the biggest number. That's the 16. Does 8 go into 16? Yes, then that's your common denominator. If 8 doesn't go into 16, then you do the multiples of your biggest number on the bottom till the other number goes into it. That's the best way to do common denominator. Now, my way of doing common denominator is 16 divided by 16 is 1. 1 times 1 is 1. And then my minus sign right there, 16 divided by 8 is 2. 2 times 1 is 2. All right. So now we have 1 over 1 minus 2 is negative 1 over 16 to the power of negative 1. Now, this becomes 1 over 16 over negative 1 to the power of 1. Now we resorted to this rule where if you have a negative exponent outside and you have one fraction inside, you could flip it and make the exponent positive. Sorry, and that's a 1, not 2. Okay. So that one, you don't really need to write it. And 16 divided by negative 1 is negative 16. So your final answer will be 1 over negative 16. I prefer writing it as negative 1 over 16. We don't like writing negatives on the bottom of a fraction. Okay, so let's go to 2 more questions. They are not negative exponents. So on a second here, I'm just going to explore these. So here we go. It's a bit different from what we did in the earlier questions, but same laws apply when you're multiplying variables that are the same. You add their exponents. If you're dividing, you subtract their exponents. So the first thing I'm going to do, the top, multiply these two, and then see what I'm going to get. So basically, this is going to give me m, and you're adding exponents. So x plus 2x is 3x. And then negative 1 plus 5 gives you plus 4 to the power of m to the power of 3x minus 1 on the bottom, sorry. Now, here when you're dividing, you minus the exponents, okay? But what's the common mistake we see here is when you're dividing and you're minusing the exponents, okay? So it's 3x minus 3x would cancel, because when you're minusing the exponents, they would cancel, because when you're dividing, you minus the exponents. But here, it's 4 minus negative 1, which will give me 5. The common mistake we see here is m to the 3. And, you know, when I was in high school, I had an Egyptian teacher that really helped me with, like he had the most influence on me in mathematics. And he always said, you know, Sammy, just have a long line in your piece of paper. Back then we didn't have computers and stuff, but we, you know, on your notebook, just put a long line and do all your scrap work here. So for me, if I'm minusing here, I don't want to make mistakes. So I say, okay, I'm going to rewrite this. I have to minus the exponent. So 3x plus 4 minus brackets, 3x minus 1. Always when you're minusing a binomial, this is a binomial, 2 terms, put it in brackets, because you know that you have to distribute that negative n, and it's going to give you negative 3x plus 1. And now, like terms, you know, going back, 3x minus 3x is gone, 4 plus 1 is 5, and that's how I get m to the 5. So that's what you're supposed to do. I highly advise, doing that. I always like this because you do your scrap work here and then the teacher could go and take a look at it. But here your work is really nice and clean, So one more question for this session. So here's a question that's a little bit different from what we've done so far. It's you have to change here because we don't have the same basis. We have to change all of this to the same base, So the base that I could see that all of them could share, 8 could be changed to 2 squared. Like if the 8 wasn't there, then and just the 4 and the 16, we could have just changed the 16 to 4 to the power of 2. But 8, we cannot change it to 4 to the power of anything unless you're good with doing fraction exponents and stuff like that. And I don't recommend anybody to do that. But here, all of them, I could see that I could express them as a base of 2. 8 is 2 cubed, so I could change this to 2 to the power of 3, and I still have the 1 minus 2x lingering outside there. And times 4, we're changing them all to base of 2, and the 4 could be expressed as 2 to the power of 2, and we still have the 2x plus 3 besides that. And the 16 is 2 to the power of 4 because that gives you 16, and then we have the 2 minus 3x in there. And now we're allowed to use the exponent laws because all the bases are the same. But before we do that, I guess we have to do a little bit of simplifying. So now just distribute that into here and to there. You get 3 minus 6x times 2. That's going to give me 4x plus 6. And then on the bottom right here, we're going to get 2 to the power of 8 minus 12x. The top here is going to give me 2 to the power of, you add the exponent, so that 3 plus 6 is going to give me 9, and negative 6x plus 4x is just going to give me minus 2x. And the bottom just 2 to the power of 8 minus 12x. And then when we're doing this here, dividing, we minus the exponents, and then I'm going to go back to what my Egyptian teacher have told me. I got to do my scrap work right here so I make sure I don't make a mistake. All of us remember through our school career that we always had a teacher that we remembered. It's just that teacher that inspired something in you. And I always remember this teacher. So there we go, back to the long line on the side of the page. And I'm going to take the 9 minus 2x. So I don't want to make any mistakes here. Minus brackets, minusing a binomial, always throw it in brackets because a negative is a sign changer. If you do that, you'll eliminate the chance of making that mistake that we see all the time marking students' exams and tests. They forget to distribute that negative end, and it's very easy to forget. So when you're doing something like this and you're looking at this and think, wow, this is complicated, and your train of thought forgets that that's negative 2x minus negative 12x. But if you do that, then you'll make sure that you don't make that kind of mistake. So 9 minus 8 here, the like terms gives me 1, and negative 2x plus 12x gives me plus 10x. So therefore, my clean piece of paper right here gives me 2, and then I could just put that 1 plus 10x as my final answer for that one. This is it for today. As always, thank you for watching. Stay tuned for my next video. Take care. Bye-bye.